Good afternoon. Today we'll be looking at the June 29, 2019 Paper 1. So we are going to go right ahead and start. All right, question 1 is on measurement, and it says 3.141592 expressed as two significant figures is. Now, what we know is that all non-zero digits are significant, so we should have 2 digits in our number for our answer, and therefore the logical answer would be 3.1. The answer should be A. Number 2, to measure the external diameter of a measuring cylinder most accurately, one should use a. Now the most appropriate instrument there would be the vernier caliper, because it is equipped with internal jaws so that it can measure inside diameters. The answer should be B. Number 3, a 4 kilogram mass is traveling with a constant speed of 5 meters per second. It is brought to rest in 2 seconds, and you have to find the average force. So we can use Newton's second law, in which the equation says that the rate of change of momentum would give us the force. And so the force is equal to 4 multiplied by the change of momentum, which would be 0 minus 5 in this case, divided by 2. However, we are not going to include the negative sign in our answer. So the answer is 10, and the closest thing is C, 10.0 Newton. Number 4, we have a body that is acted upon by 2 forces X and Y, which are going in the same direction, that is to the right. What force is required to keep the body steady? And we know that for the body to be steady, the resultant force must be equal to 0, and therefore we want a force acting to the left, which sums up to X and Y. So the answer is X plus Y to the left. So that's B. Number 5, a boy measured the height of a laboratory table with a meter rule. Which of the following is most likely to be correct? Now, a meter rule can measure up to 1 millimeter accurately, which is 1/1000th of a meter. And the other thing we should bear in mind is that tables are not generally several meters high, nor much lower than a meter. And therefore, we can rule out the first answer A, also the second answer B. We're left with C and D, and we know that 8.95 would be very tall for a table. So logically, your answer should be 0.895 meters. C. Number 6, we have several diagrams which are not drawn to scale. With two forces S and T, they are acting at a point O, which diagram correctly shows the resultant OX. Now, if we draw a parallelogram, so if you are doing the actual question on a paper, you could draw a parallelogram to match the diagram and see which diagram is most suitable. But the thing is that A would be more suitable because when we look at S and T, their direction, then OX would be going in a direction which pretty much is balancing S and T. In diagram B, OX is going too much over to T, and T is a smaller force. So you should not have that happening. The answer should be A. Number 7, when an astronaut is standing on the moon, his mass is 70 kilograms. When he returns to Earth, his approximate weight will be. So in this case, we need to understand the difference between mass and weight. However, if we want to find weight, we have to multiply the mass times the gravitational field strength, which is approximately 10 newtons per kilogram. The mass remains the same. You have to remember that. So even though he returns to Earth, his mass is the same, but his weight will be different. So his weight is 70 times 10. That's B. Number 8, which of the following rates will determine the power of a machine? Power is defined as the rate at which work is done, or the rate at which energy is converted from one form to another. So a change in temperature would not give us power. So it's 1 and 2, and your answer is C. Number 9, which of the following features must be present in a stable, well-designed racing car? And we know the two most important factors that affect the stability of a body are low center of gravity and wide base area. So only one here, low center of gravity, applies. The answer is D. Number 10, the time period of a simple pendulum oscillating with a small amplitude depends on. Now there are two things that the oscillation depends on, the period, and those are the length of the pendulum and the acceleration due to gravity, which if you are in one place, then that would be constant. So it only depends on the length. The answer should be C. Number 11, pressure in a liquid can be calculated using the formula P equal rho GH. Which of the following sets of units will result in SI unit of pressure? So all your quantities should be in SI units. Rho is measured in, like rho is the density, so that's SI unit kilogram per cubic meter. G is measured in newtons per kilogram, and H is measured in meters. So the answer should be B. Which of the following is the unit of momentum? Momentum is the product of mass and velocity. So if we multiply the unit of mass, which is kilogram, by the unit of velocity, meters per second, then we get kilogram meters per second, and that's B. Number 13, which of the following quantities has the same value as 6 microcoulombs? This symbol here means micro, and that is 10 to the minus 6. And so your answer should be D. 14, which of the following is an SI base unit? We know that ampere is SI unit of electric current, and electric current is a fundamental quantity. So ampere would be your answer. Number 15, this shows a displacement time graph, and you are to interpret what what can you deduce from the runner about the runner, and we know that the gradient of a displacement time graph gives us the velocity, or if you want to say the speed. So since the graph is a straight line graph, it means that the gradient is constant, and therefore the runner is going at constant speed, which is steady speed b. Number 16, an object is removed from the ground and placed on a shelf. Which of its properties is expected to increase? So we know that when work is done against gravity, an object gains potential energy. It doesn't gain anything else. So your answer should be C. Which of the following is the poorest conductor of thermal energy? And we know that copper, mercury, and aluminum are metals. Metals are generally good conductors. So you can just use that to find your answer. And so your answer is A, here. Boyle's law for a gas can be tested experimentally provided which of the following remain constant. In Boyle's law, we have a fixed mass of gas, so the mass of the gas is constant, and also the temperature. All right, so temperature and mass 1 and 3, that's B. Number 19, which of the following are characteristic features of a clinical thermometer? Now we know that clinical thermometers have a narrow range, so limited range 2, and also a narrow constriction. All right, so 1 and 2. A large bore would not make sense in a clinical thermometer because the larger the bore, the more inaccurate or the less sensitive the instrument will be. So it's 1 and 2 only. So that's A. 20. A metal of mass M requires energy E to raise its temperature from T1 to T2. The specific heat capacity of the metal will be given by, so we know that T, which is the specific heat capacity, is equal to energy divided by mass times the temperature change. And the temperature change in this case will be T2 minus T1. So energy divided by M times T2 minus T1, that's V. 21. The specific latent heat of vaporization of water is 2.26 times 10 to the 6 joules per kilogram. When 0.01 kilogram of water is converted into steam, what happens? Now we know that for water to become steam, heat must be absorbed, so you can eliminate B and D, leaving with A and C, and then energy is found by multiplying the mass times the specific latent heat, so 2.26 times 10 to the 6 times 0.01. That will give you 2.26 times 10 to the 4th, and your answer is A. 22. A gas occupies 2 cubic meters at 27 degrees Celsius at a pressure of 1 atmosphere. At a pressure of 2 atmospheres, it occupies a volume of 1 cubic meter. What is the temperature at this new volume and pressure? Now, we can use the combined, well, we have to use the combined gas law to find this. If you're working it out, or you could use a logical reasoning. So, reasoning it out, we have 2 meter cubed That's the volume, and the pressure is 1 atmosphere. So P times V would be 2. And in the second instance, we have 2 atmosphere and 1 cubic meter. That's 2 times 1, that's 2 again. So if P and V is 2 in both initial and final, it means that the temperature would have to be constant. So the same temperature applies here, and that's 27.0 degrees Celsius. That's B. 23, which of the following statements concerning the radiation of heat is or are true? Radiation can take place in a vacuum. So number 1 is false. A good absorber is also a good emitter. That's true. And dark, those surfaces are better emitters than shiny ones. That's also true. So it's 2 and 3 only. The answer is D. 24, which of the following quantities remain unchanged with an increase in temperature? When a substance is heated, its volume increases, mass doesn't change, so the density will change. All right. So the mass remains unchanged, and your answer is A. 25. Some molten naphthalene at 100 degrees Celsius is allowed to cool to room temperature. If naphthalene has a melting point of 80 degrees Celsius, which of the following graph best represents the cooling curve? And so what we can use is that during a phase change, the temperature of a substance remains constant. And so you look for a graph which has some constant part, and that's E. And it also corresponds to 80, so where the melting point is, the line remains constant for a while. The answer should be C. Number 26, an electric kettle full of water is plugged into the mains. The major process by which heat travels through the water is, and convection is the main process through which heat travels in a liquid. And so convection is the answer B. 27, we have in using a slinky to demonstrate longitudinal waves moving from point A to point B above, the spring is made to vibrate. So in a longitudinal wave, the direction of the wave disturbance is parallel to the direction of energy transfer. And so you should have parallel to A and B, parallel to AB, that's A. 28, in which of the following is conduction the main method of energy transfer? And you know that conduction is the main way in which, or the only way in which heat travels in a solid. And what you can look at in a microwave, the energy is not in contact directly with the food. So there is a gap between where the energy is and the food, just like in the case where energy is transferred from the sun to the earth. They are not in direct contact with each other. Food being cooked on a barbecue, this is also not a case where the source of heat is directly in contact with the food. And so your answer is D. 29. Which of the following statements does not provide evidence that sound can be reflected? Now, sound traveling around a corner is an indication of diffraction, not reflection. So your answer should be A. Number 30. So you have a diagram showing a tube of water and ice wrapped in a gauze at the bottom. The water at the top boils and the ice remains unmelted. What does that tell you? Liquids are poor conductors. So water is a poor conductor of heat. That closely matches what this is saying. And another thing you can look at is that it takes more energy to boil, to get water to boil than to melt the same amount of ice. So 1 gram of water from zero to take it from 0 to 100 degrees Celsius requires more energy than to melt 1 gram of ice at 0 degrees Celsius. Your answer should be A. All right. So at this point, Miss Rose will come in.
Mm. Good evening, everyone. We're going to be continuing from item 31.
You're gonna use your screen. Oh, yeah.
Yeah. Right. So we're at number 31 now. Wherever or whenever there's complete destructive interference between two coherent wave trains, the waves must be, and we have our options there. Now, whenever there is destructive interference, the waves must be exactly out of phase, which means that they need to be out of phase by half of a wavelength. All right. So our answer there is B. Item 32, we have a diagram here with some points along a wave, and we want to find out which statements are true. We have P, Q, and R in phase, S and T are out of phase. The wavelength is the distance PR. Now, points that are in phase, they tend to be separated by a whole number of wavelengths. So it means, therefore, that P, Q, and R, they are separated by half of a wavelength. So that one would be out. And S and T are out of phase, which is true. The distance PR is the wavelength, and we have one point P here and point R. Both of them are at the same point in their motion. So our answer here would be C. Right, number 33, an echo is quieter than the original sound that produced it. This shows that compared to the original sound, the echo has a, and we know that amplitude is directly related to the loudness or the intensity of a sound. The smaller the amplitude, the softer the sound will be. So our answer is A. Number 34, which of the following produces a diminished virtual image of a real object? Now, converging lenses almost always produce um, real images, and when they do produce virtual images, the image is not diminished. So diverging lenses will always produce diminished and virtual images of a real object. So that's B. Number 35, we have an object O that is viewed in a plane mirror, PQ, and we are asked to identify which diagram shows the formation of the image. Now we know that the object is actually, the light rays from the object will be produced or reflected from the mirror line and into the observer's eye. That's one thing we need to note. And also remember that for images formed from plane mirrors, the distance that the object is from the mirror is equal to the distance that the image is from the mirror as well. So that's why D is not the answer, because the distances here are not the same. So that leaves us with option A. Number 36, which diagram best describe represents the wave generated in a ripple tank by a small spherical dipper vibrating at constant frequency. Now, the frequency has to do with the number of waves or the number of oscillations that occur in in a second. So if it's constant, then it means that we need to have the same number of waves being produced at each second. Therefore, the wavefronts should be equidistant to each other, and that would give us A. Number 37, which of the following statements about waves is true? and we have some statements there. Now, all waves undergo these four phenomena: reflection, refraction, diffraction, and interference. So it means that option C is true. 38. A ray of white light enters a transparent glass prism. In which of the diagrams is the dispersion of light correctly illustrated? Now, based on what we know about deviation and dispersion, the light is going to be split into its constituent colors, with red being deviated the least and violet being deviated the most. That's option A. Number 39. Which diagram represents the magnetic field that exists between two opposite magnetic poles? Now we know that opposite poles will attract, and one thing that we ought to remember is that when we draw magnetic field lines, they always point outwards from the north and towards the south pole. So that would eliminate option B, and that would leave us with C for our correct answer. Number 40. Which of the following diagrams is a graphical representation of current versus potential difference for a metallic conductor at constant temperature? Now, metallic conductors are devices that obey Ohm's law at constant temperature, which we call ohmic devices. It therefore means that a graph of current versus voltage will yield a straight line from the origin, which shows that there is direct proportion between the current and the voltage. That's D. Number 41, we have a diagram here of a transformer, and we're asked to label it in terms of the type of transformer and what type of input. Now, transformers use AC input in order to produce an alternating magnetic field, so it means that B and D would be out. Now, to determine whether it is step up or step down, we look at the number of turns on the coils. A primary, the step-up transformer has more turns on the secondary coil, so that gives us option C. Number 42, all right, we have a diagram here, and we're asked to match the component names with the numbers. For this one, you only need to know which component is correctly matched for one of them. So for instance, if you identify that this is a lamp, it's number 1. So it means that option A must be the answer. All right. Number 43, sorry. Which of the following equations cannot be used to determine the power dissipated in a resistor? Now, we know that power can be calculated by multiplying the voltage by the current, and then we can use Ohm's law to substitute, and we can end up with power equals to the square of the current times the resistance. We can also substitute I for V over R, which would give us V squared over over R. So A, B, and D can be used to determine the power, but option C cannot. Number 44, right, we have a truth table for a gate that has two inputs A and B, and the output is C. Now, based on this, we can see that the only time that we have a low output is if both inputs are high, and that corresponds to the NAND gate, and then all other combinations will give a high output. So that's option A. Item 45 refers to a circuit where we have an ammeter reading 0.4 amperes and the voltage is 0.6 volts. Now we're asked to calculate resistance. Now we know that Ohm's law says that voltage is equal to current times resistance. So we transpose for R, which will give us the voltage divided by the current, and that gives us 1.5 ohms, which is B. At number 46. Now we have a diagram here of a simple AC generator, and we are asked to label parts X. Now we know that in a generator, these components are rings, and we call them slip rings. In the motors, we use split rings. but because this is a generator, it is the slip ring, and that's option C. Right, number 47, which statement about alternating current is true? Now we know that transformers will alter the voltage of the AC, doesn't change it into direct current. Batteries are recharged using direct current, not alternating current. And alternating current is used to transmit electrical energy because of the fact that it can be produced at high voltages and not necessarily because of high frequency. So that leaves us with option B. In which of the following diagrams are P and Q in series with each other and in parallel with R? A series circuit, you have one path for current to flow, and a parallel circuit, there is multiple paths. So if we look at option A, you realize that there is only one path for the current to flow between P and Q, and they both are in parallel with R, which gives us A. Right? Which graph illustrates an alternating current? Now, in alternating current, the current flows in both directions, which means that it would take up the positive portion of the graph as well as the negative portion, which gives us D. All of these other options are actually direct current. Number 50, magnetic induction occurs when, and we have our options here. Now, whenever iron nails are placed near a magnet, the end of the iron that is nearest to the magnet actually attains an opposite pole. So it actually causes attraction now. And that is why we have the iron nails becoming magnetized. And that's as a result of induction. So that's D. Number 51, which of the following pairs of statements is true for iron and steel? Now, iron is magnetically soft, which means that it is easily magnetized. So B and D are out. Steel, on the other hand, is magnetically hard, which means that it retains its magnetism well, even though it is not easy to magnetize. So that gives us C. Item 52, we have a diagram that represents a straight wire carrying a current into the plane of the paper. Now we can use Maxwell's right hand grip rule, which states that if we point the thumb in the direction of the current, then the fingers will curl in the direction of the field. Now, the field is going into the paper, so we'd point our thumb downwards into the paper, and our fingers would coil clockwise, which gives us D. Number 53, which of the following are possible symbols for an isotope of this nuclide? Now, isotopes will have the same proton number, which is Z. So any option that has Z for the proton number would be a radioisotope. So that's 1 and 3. That's B. Right? Carbon 14 decays in accordance with this equation here, and we're asked to find out what the emission X stands for. Now, in these types of reactions, though the number of particles is conserved or mass is conserved, so it means therefore that we need to find the particle that will have a 0 at the top and -1 at the bottom, and that corresponds to a beta particle, which is option C. In the equation delta E equals delta mc squared, you're asked to say what C stands for and what delta M stands for. Now, this is Einstein's famous equation. C stands for the speed of light, and delta M is the mass deficit or the mass that is lost based on the reaction. That's B. The number of neutrons present in the nucleus of the nuclide Rn, and it has 222 for the mass and 86 for the proton number. To find the number of neutrons, we subtract the number of protons from the number of nucleons or the mass number. So we would subtract 86 from 222, and that gives us 136, which is C. Number 57, which of the following describes two properties of an alpha particle? Now, alpha particles are synonymous with helium nuclei, which means that they have positive charges, which would eliminate A and C. And we also know that alpha particles are not very penetrating. So that's D. Number 58, sodium 24 decays into magnesium 24 with the emission of a beta particle and can be represented by the equation that is given. Now we need to figure out what needs to be placed in the box to complete the equation. Now, once again, we know that the number of particles is conserved in a nuclear equation. So it means that we need the particle that has 0 for the mass and -1 for the charge. That's option B, which is a beta particle. Which of the following scientists discovered the relationship E equals mc squared? Now, as we had just said earlier, that is Einstein's famous equation, which means that our answer is D. And finally, we have a radioactive isotope that has a half-life of 20 days. How many days will it take for a given sample to have its activity reduced to 1/8 of its initial value? Now, 1/8 of its initial value means that the substance would have decayed by half 3 times, because a half to the power of 3 is 1/8. And that means, therefore, that 3 half-lives would have taken place. After the first half-life, you would have, that would be 20 days. After the second half-life, it would be 40 days. And the third half-life would be 60 days. That's B. All right, so I'll hand over back to Mr. Campbell this time.
All right. Thank you, guys. All right. Thank you, guys, for being here. And, you can check out our website, onlinesciencetutor.net, or follow us on Instagram, Online Science Tutor, Facebook, CSEC Science Tutor 1. All the best.